Okay, guys, we're going to be in chapter 7, lessons 5 and 6 this week. And we're going to be talking about something called exponential functions. So we're going to start by graphing them so we get an idea of what they look like. And we're going to start with a very simple one, and we're going to be just kind of focused in on that. And we're going to be doing, like I said, graphing and breaking them down into two major groups. Okay, so let's first start with a definition. What is an exponential function? So an exponential function is a function in the form, so here we go, another form, y equals ab to the x. So the exponential function has an exponent that is the x. Now the a and the b and the y are all numbers. Okay, so for a, we have some stipulations. A can't equal 0. If it equals 0, then we get y equals 0, which means we get a horizontal line where y is, and that's not going to be an exponential function. And then we've got our b value. We've got two stipulations about him. First, it needs to be positive, so it's got to be greater than 0. And the second thing is that it can't equal 1, because that way we wouldn't get any unique ordered pairs, because it doesn't matter what exponent's on 1, it still equals 1. Okay? So the interesting thing about this graph is that it's not going to be a line. So this is, it is a non-linear graph. Okay, and we've got a couple of interesting pieces of information. The graph approaches the x-axis, but never intersects. So the form that we're studying, since we're introductory, our graphs, generally speaking, are going to be above the x-axis. Okay, now it is possible to have graphs that go below the x-axis, but then that's going to deal with a slightly different form than what we're paying attention to right now. Now, I am going to give you a little word, and we're going to say that the x-axis is going to be what is called an asymptote. Asymptote. Okay? And basically, that's a fancy word of saying a line that a graph approaches but doesn't intersect. Okay? And then, but on the other hand, your graph should cross the y-axis. Or should intersect the y-axis. So we're going to have a y-intercept. And remember, the coordinates, the x-coordinate is going to be 0, and the y-coordinate is the y. Now, these type of functions break down into two groups. We have an exponential growth function, so I'm going to draw a picture of that, or a graph of it, actually, I should say. Just so we know. And so we start off low on the x's, and as our x's, and on the y's, and then as our x's increase, our y's increase. So the graph shows an increase. To get that, as x increases, y increases. Now remember, when we read a graph, we always go from left to right. We talked about that oodles of time ago when we were dealing with just basic functions, right? So in this case, the a value is positive, okay, which means the a value can be negative. Isn't that interesting? And then the b is going to be greater than 1, okay? The other form is going to be an exponential decay function. So let's draw that. And you can see straight away the difference in these graphs. Okay, so this one, the graph shows a decrease. And by that, as x increases, oops, sorry. Y decreases. So as your x gets bigger, your y gets smaller. Okay, let me go back and draw an arrow over here too. So a couple of things to note on this particular graph. My a is still going to be positive because we're above the x-axis is one of the reasons. And then the b value, though, is going to be between 0 and 1. It can't equal 0, okay, and it can't equal 1. So it's in between, which means it's a fraction. Okay, so I'm going to go to my next screen and talk about, well, how on earth are we going to graph? So we're going to talk about that to graph. So we're going to need a minimum, I like to use more than this, a minimum of 3 x values. And remember, just like with all graphing, you want to have 3 points, because if you only have 2, you'll get a straight line, but you don't know what it is. But because this is going to have a curve to it, we definitely need 3. I would suggest 5. So what are we going to choose? Well, we're going to choose x to equal 0, okay? And the reason why we're going to choose that is that's anything to the 0 power equals 1. So that makes it for easy calculating, okay? So if x is equal to 0, then b to the x would equal 1, and 1 times a is a. So that would draw to the conclusion that we get y is equal to 0. Okay, so that is going to, or y is going to equal your a value. So that's going to equal the y-intercept. Because when I plug in 0, I get out the a value. Okay? And then you should also have one additional negative and one positive. So additional negative, that came out funny sounding. Oh, positive. Okay? Now, personally, using a table of values is good. So you can show your work there. So once we choose our x's, then we're going to calculate corresponding y values. Okay, and then we're going to graph the 3 or more ordered pairs. Personally, I'm going to go with 5, so you'll see that. Now this one you can't just connect, you're going to have to sketch because we've got this curve coming in. Sketch out the curve. Okay, so a couple of key points about that curve. It will approach but not intersect the x-axis. Okay, we talked about that before. And then you need to watch the b value. Okay, so if b is greater than 0 or positive, that means you should have an increase in y. Okay, so keep that in mind. Now, if b is a fraction, okay, so again, if b is positive, we're talking about growth. It's a growth function. But if b is a fraction, then there's going to be a decrease in y, or a decay. Okay? All right, so I'm going to go to my next screen, and I'm going to graph. Okay, so we're going to do 3 graphs, just so you get a feel for it, and the directions are just going to say simply that, graph. So we're going to be given y equals 3 to the x power. Okay, so the first thing I want to do is identify my key players, which are my A and my B. So A would be in front of the base, so since I don't see it, it means it's 1. So keep that in mind. The invisible 1 times the 3x. The B is the 3. Okay, so keep that in mind. So I'm going to go ahead, choose my x's. I'm going to do my work in the middle column, or the second column, I should say. I'm going to get out a y value, and then I'm going to write them as an ordered pair. So I like to choose -2, -1, 0, 1, 2, especially because of the curve. It's just going to make it a little easier to see it. So I'm going to get y equals 3 to the -2 power. So a negative exponent just means that I'm going to write it 1 over. So I'm going to do reciprocal, and then I do the math, and I get 1/9. So here's the weird part, is you might be graphing some fractions, so it's just going to be a little bit of an estimation. Next one, y equals 3 to the first power. That's easy, right? Oh, sorry, negative first power. Let's try that again. Oop. Negative first power. So again, I'm going to have to write it as a fraction. It would be 1 over 3 to the first, which equals 1/3. So -1, 1/3. So negative exponents on a whole number base is going to give us fractional answers, unless we've got an a value that doesn't equal 1. That could eliminate things. So now we're going to have 3 to the 0 power, and we know that anything to the 0 power equals 1. So 0, 1, and that happens to be the x-intercept. So then we're going to try 1, so 3 to the first power is simply itself, 3. So 1, oops, why did I write that? Because I'm looking at the 2, that's why. And then the last one, we've got y equals 3 squared, and that's going to equal 9. So we have 2, 9. So then we're going to go ahead and graph this. Now what would be good is to have graph paper. Okay, so very important to have graph paper. So we have x, we have y. So we have 1, 2, 1, 2. And then we're going to get only positive y values. So 2, 4, 6, 8, 10. Okay, then we're going to graph those points. So at -2, it was 1/9, so that's pretty low. And then at -1, it was up a little higher. And then at 0, it went to 1, a little higher. At 1, it went up to 3, and notice what happens. All of a sudden, it just starts jumping up. 2, bam, up to 9. So that's what exponential growth is. It doesn't grow by adding, it grows by raising to the power. So that's where we're going to end up getting a very quick growth. Now, what we can tell, and we should have been able to tell just by looking at the b value, this is going to be a growth, right? Because your b is positive, and we can see that that is definitely a growth. Okay, let's try another one. And we've got y equals 1/2 to the x power. So I'm going to put my values below it. So a, again, we can't see it. It would be in front of the 1/2, so it's 1. And then the b value is going to be 1/2. So if we have a b value that's between 0 and 1, that means we should have a decay happening, because things are going to get cut in half. All right, so let's do our table. So we're going to have x, and we'll have y equals 1/2 to the x power. We get results and combine them up for an ordered pair. And I'm going to use my 5 favorite. So when I plug in -2, okay, so what that's going to do is it's going to flip, take the reciprocal of the base, and then the exponent would be positive. So when I put in a -2, I get 2 squared, which gives me 4. So -2, 4. So definitely I'm starting up with high y values. And then I plug in -1 for the second one, which is going to take the reciprocal, and that's just going to give me 2. So notice all of a sudden now my y's are decreasing, whereas in the other case, the y's increased. All right, let's go to 0. That's an easy one to calculate, because anything to the 0 power is equal to 1. So we get 0, 1. Hey, that's interesting. Same y-intercept as the last problem. So let's put in 1, the first power, I should say. And that's going to just give me 1/2. Yep, ever decreasing on my y's as my x's increase. So then we have squared, and that's going to be equal to 1/2 times itself, which gives me 1/4. So my last ordered pair is 2 1/4. All right, so let's see, we need to go 4 and 2s. Okay, we'll do this. Here's x's, y, 1 2 1 2 1 2 3 4. Okay, so go ahead and plot those points. So, oops, let's try that again. -2, thank you very much. So -2 up to 4, and then -1 up to 2, 0 is at 1, 1 is at 1/2, and 2 is at 1/4. So if I sketch this out, definitely a decay going on. Don't forget those arrow caps. All right, let's see if we can squeeze one more on here. So our third one, haha, we are going to get an A value, different than 1. Ooh, and a fraction. So my key players, A is 3, B is 1/4. So here's what I understand, is that it should be a decay because I have a fractional B value. All right, so we're going to have some extra calculations on this one because of the A value not equaling 1, equaling 3. Okay, I'm going to choose my 5 favorite. Okay, so we're going to get y equals 3 to the 1/4, and we're going to raise that to the negative second power. So what that says is we're going to take the reciprocal of 1/4, which is 4, and we're going to square it. However, remember this, there's a 3 there. Sorry, not a 4. There we go. Okay, so we get, oh my word, 4 squared is 16, and we get 3 times 16 is 48. This might make for some troublesome graphing, huh? So we get -2, 48. Whoa. All right, next one. I'm going to raise that to the 1/4. I'm sorry, negative first power. And we get 3 times, let's see, got to do a reciprocal, 4, and that equals 12. Definitely decreasing on our y's as our x's increase. And then we're going to put in 0 as our exponent. And that's going to give me 3 times 1, or 3. So that's my y-intercept, a little different this time. Okay, and then we're going to plug in 1. For my exponent. And that's going to give me just 3 times 1/4, which is 3/4. Ooh, fraction, lovely. And last but not least, we put in the 2. Oops, not there. Try that again. So that's going to give me 3 times 1/4 times itself is 1/16. And then that's going to give me 3/16. So 2 3/16. Okay, so here's my graph. Let's see, how do I want to do this? Now, generally speaking, remember we said we needed 3 numbers to graph. But to get all the way up to 48 is going to be a big old pain. So what we're going to do instead is we're going to get up to the 12. 2, 4, 6, 8, 10, 12. That's y, that's x. 2, negative 2. Okay, let's graph those points. So when x was negative 2, we went up to 48. So that's going to be way off of this chart, so I'm not even going to graph it. When I put in negative 1, I got it all the way up to 12. Okay, when I put in 0, I got to 3. Big jump. When I put in 1, I got 3/4. And when I put in 2, I got 3/16. So I'm going to sketch it. So notice the others were kind of broad. And look at how kind of narrow this one is. That's the fault of the 3. And there you go. All right. Good luck with this, guys. We'll talk about it in class. Bye now.